In some cases, the Oracle server receives data of one data type where it expects data of a different data type. When this happens, the Oracle server can automatically convert the data to the expected data type. This data type conversion can be done implicitly by the Oracle server or explicitly by the user. Implicit data type conversions work according to the rules explained in the following slides. Explicit data type conversions are performed by using the conversion functions. Conversion functions convert a value from one data type to another. Generally, the form of the function names follows the convention data type TO data type. The first data type is the input data type and the second data type is the output. Oracle server can automatically perform data type conversion in an expression. For example, the expression higher_date greater than the 1st of January 90 results in the implicit conversion from the string the 1st of January 90 to a date. Therefore, a varchar2 or char value can be implicitly converted to a number or date data type in an expression. In general, the Oracle server uses the rule for expressions when a data type conversion is needed. For example, the expression grade equals 2 results in the implicit conversion of the number 2 to the string 2, because grade is a char 2 column. SQL provides 3 functions to convert a value from one data type to another: to underscore char, number, date, fmt, NL sparams, equals. Converts a number or date value to a varchar2 character string with the format model fmt. Number conversion. The NL sparams parameter specifies the following characters, which are returned by number format elements: decimal character, group separator, local currency symbol, international currency symbol. If NL sparams or any other parameter is omitted, this function uses the default parameter values for the session. To underscore number, char, fmt, NL sparams, equals. Converts a character string containing digits to a number in the format specified by the optional format model fmt. The NL sparams parameter has the same purpose in this function as in the to underscore char function for number conversion. To underscore date, char, fmt, NL sparam. S, equals. Converts a character string representing a date to a date value according to fmt that is specified. If fmt is omitted, the format is ddmonYY. The NL sparams parameter has the same purpose in this function as in the to underscore char function for date conversion. To underscore char converts a datetime data type to a value of varchar2 data type in the format specified by the format underscore model. A format model is a character literal that describes the format of datetime stored in a character string. For example, the datetime format model for the string, the 11th of November 2000, is ddmonYYYY. You can use the to underscore char function to convert a date from its default format to the one that you specify. Elements of the date format model. YYYY. Full year in numbers. Year. Year spelled out, in English. M. 2-digit value for the month. Month. Full name of the month. MON. 3-letter abbreviation of the month. D. Y. 3-letter abbreviation of the day of the week. Day. Full name of the day of the week. D. Numeric day of the month. Elements of the date format model. Time elements format the time portion of the date, HH24, M. I, SSAM, 15 hours 45 minutes and 32 seconds PM. Add character strings by enclosing them with double quotation marks, DD, of, month. 12 of October. Number suffixes spell out numbers, D, S, P, T, H. 14th. The SQL statement in the slide displays the last names and hire dates for all the employees. The hire date appears as the 17th of June 2003. When working with number values, such as character strings, you should convert those numbers to the character data type using the to underscore char function, which translates a value of number data type to varchar2 data type. This technique is especially useful with concatenation. The Oracle server displays a string of number signs, hash, in place of a whole number whose digits exceed the number of digits provided in the format model. The Oracle server rounds the stored decimal value to the number of decimal places provided in the format model. You may want to convert a character string to either a number or a date. To accomplish this task, use the to underscore number or to underscore date functions. The format model that you select is based on the previously demonstrated format elements. The fx modifier specifies the exact match for the character argument and date format model of a to underscore date function. Punctuation and quoted text in the character argument must exactly match, except for case the corresponding parts of the format model. The character argument cannot have extra blanks. Without fx, the Oracle server ignores extra blanks. Numeric data in the character argument must have the same number of digits as the corresponding element in the format model. Without fx, the numbers in the character argument can omit leading zeros. To find employees who were hired before 1990, the RR format can be used. Because the current year is greater than 1999, the RR format interprets the year portion of the date from 1950 to 1999. These functions work with any data type and pertain to the use of null values in the expression list. NVL converts a null value to an actual value. NVL2. If EXPR1 is not null, NVL2 returns EXPR2. If EXPR1 is null, NVL2 returns EXPR3. The argument EXPR1 can have any data type. Null. If compares two expressions and returns null if they are equal, returns the first expression if they are not equal. Coalesce returns the first non-null expression in the expression list. To convert a null value to an actual value, use the NVL function. Data types that can be used are date, character, and number. NVL conversions for various data types equals number. NVL, number underscore column, 9. Date. NVL, date underscore column, the 1st of January 95. Char or varchar 2. NVL, character underscore column, unavailable. To calculate the annual compensation of all employees, you need to multiply the monthly salary by 12 and then add the commission percentage to the result. Notice that the annual compensation is calculated for only those employees who earn a commission. If any column value in an expression is null, the result is null. To calculate values for all employees, you must convert the null value to a number before applying the arithmetic operator. In the example in the slide, the NVL function is used to convert null values to 0. The NVL2 function examines the first expression. If the first expression is not null, the NVL2 function returns the second expression. If the first expression is null, the third expression is returned. Syntax: NVL2, EXPR1, EXPR2, EXPR3. In the syntax, EXPR1 is the source value or expression that may contain a null. EXPR2 is the value that is returned if EXPR1 is not null. EXPR3 is the value that is returned if EXPR1 is null. In the example shown in the slide, the commission underscore PCT column is examined. If a value is detected, the text literal value of sal plus com is returned. If the commission underscore PCT column contains a null value, the text literal value of sal is returned. The nullif function compares two expressions. Syntax: nullif, EXPR1, EXPR2. In the syntax, nullif compares EXPR1 and EXPR2. If they are equal, the function returns null. If they are not, the function returns EXPR1. However, you cannot specify the literal null for EXPR1. In the example shown in the slide, the length of the first name in the employees table is compared to the length of the last name in the employees table. When the lengths of the names are equal, a null value is displayed. When the lengths of the names are not equal, the length of the first name is displayed. Using the coalesce function. The advantage of the coalesce function over the NVL function is that the coalesce function can take multiple alternate values. If the first expression is not null, the coalesce function returns that expression, otherwise, it does a coalesce of the remaining expressions. In the example shown in the slide, if the manager underscore id value is not null, it is displayed. If the manager underscore id value is null, the commission underscore PCT is displayed. If the manager underscore id and commission underscore PCT values are null, no commission and no manager is displayed. Note that to underscore char function is applied so that all expressions are of the same data type. The two methods that are used to implement conditional processing, if-then-else logic, in a SQL statement are the case expression and the decode function. Case expressions allow you to use the if-then-else logic in SQL statements without having to invoke procedures. In a simple case expression, the Oracle server searches for the first when, then pair for which EXPR is equal to comparison underscore EXPR and returns return underscore EXPR. If none of the when, then pairs meet this condition, and if an else clause exists, the Oracle server returns else underscore EXPR. Otherwise, the Oracle server returns a null. You cannot specify the literal null for all the return_express and the else_expr. The expressions expr and comparison_expr must be of the same data type, which can be char, varchar2, nchar, or nvarchar2, number, binary_float, or binary_double, or must all have a numeric data type. All of the return values, return_expr, must be of the same data type. In the SQL statement in the slide, the value of job_id is decoded. If job_id is IT_prog, the salary increases 10%. If job_id is saint_clerk, the salary increases 15%. If job_id is saw_rep, the salary increases 20%. For all other job roles, there is no increase in salary. The same statement can be written with the decode function. The decode function decodes an expression in a way similar to the if-then-else logic that is used in various languages. The decode function decodes expression after comparing it to each search value. If the expression is the same as search, result is returned. If the default value is omitted, a null value is returned where a search value does not match any of the result values. In the SQL statement in the slide, the value of job_id is tested. If job_id is IT_prog, the salary increases 10%. If job_id is saint_clerk, the salary increases 15%. If job_id is saw_rep, the salary increases 20%. For all other job roles, there is no increase in salary. This slide shows another example using the decode function. In this example, you determine the tax rate for each employee in Department 80 based on the monthly salary.